Hydroponics. It could be the future of food production, as it shows potential of being a suited system for food production in a circular economy. Therefore, it is no surprise that hydroponics is getting more attention from researchers, entrepreneurs, and governments across the globe. A focus group on circular horticulture of the European Commission recognized closed hydroponic systems as a key example towards a circular food production system. Let's ask ourselves the following question. How much could hydroponic system contribute in the transition towards sustainable food production in a circular economy? Before we can answer this, we need a good understanding of what hydroponics is. Hydroponics is the combination of two Greek words, hydro meaning water and ponika meaning to cultivate. Thus freely, this could be translated into water-based cultivation or cultivation on water. Plants are grown on nutritious water in controlled environments like greenhouses or other buildings, providing the opportunity to grow year-round instead of season-based. There is different types of hydroponics. The most common techniques are aeroponics, deep water culture, drip system and NFT. The most common system implementations are either outside in warm climates, greenhouse hydroponics, or vertical farming. In terms of water management, a distinction could be made between open systems and closed systems. Open systems use fresh water as an input and create wastewater, while closed systems recirculate the water. We will only consider closed systems in this video. Water-based cultivation is different than the traditional agricultural standard, the cultivation on soil. Compared to conventional soil farming, hydroponics offers several direct benefits to the grower. First of all, high water efficiency. It's stated that one can save up to 80 to 90% of water. Higher outputs. Due to the year-round production, hydroponic yields can outperform conventional farming by 5 to 10 times its yield. You need lower input requirements in terms of fertilizer, pesticides, and herbicides, and it's season and weather independent. When considering the question of how much hydroponics could contribute in the transition towards sustainable food production, once again, we can have a look at which sustainable development goals of the United Nations would mainly benefit from hydroponic food production. First of all, zero hunger. There's more control to optimize growing of crops, leading to higher yields, and diversified nutritional diet for people. Second, decent work and economic growth. It's designable everywhere in the world, could create some new jobs. And third, responsible consumption and production, because it's very resource efficient in terms of water and fertilizer that are non-renewable, for example. Back to the question that we asked before. In order to assess the sustainability and circular potential of hydroponic systems, we need to get a clear and holistic view of the entire system and its impact. Therefore, you could roughly divide it in the following attributes: pre-production and post-life, water usage, fertilizer usage, energy usage, and waste streams. We'll start at pre-production and post-life. In conventional farming on soil, one generally does not need many infrastructure in order to cultivate the plants. Within hydroponic systems, a grower will need significant amount of materials before it can start cultivating vegetables, dependent on the chosen system and skill. The grower will need materials for the greenhouse structure, system structure, piping and drainage, and water tanks. A study conducting a life cycle analysis on hydroponic systems shows that the pre-production and post-production stage of a closed hydroponic system accounts for 90% of its total impact on climate change. The focus group on circular horticulture of the European Commission concluded a very low degree of recycling in the technical materials of hydroponic systems. There is a lot of potential in reducing the environmental footprint of hydroponics, especially by recycling of steel, which could reduce the impacts of hydroponic systems on categories as air acidification and ecotoxicity by 65%. As stated before, one of the major advantages of hydroponics is the significantly higher water efficiency. Within hydroponic systems, one could have water efficiency of around 75 to 90% higher as compared to conventional soil farming. One way to improve circularity of hydroponic systems is to use recycled water as a system input. There are opportunities in using treated urban wastewater from wastewater treatment plants as water source for hydroponic production. This idea of recycling wastewater is in line with the new European regulation, which aims to encourage the reuse of treated wastewater to limit water extraction from fresh sources. On the flip side of the coin, the regenerated wastewater also often still contains loads of antibiotics and other unwanted pollutants like chemicals and hormones. More research is required to look for opportunities in utilizing this waste water for agriculture. Due to the possibility of full parameter control in hydroponics, less fertilizer is required to achieve even a higher yield per square meter. One of the foremost challenges in conventional farming is the danger of eutrophication, the unwanted enhancement of water bodies with nutrients and minerals. Within a closed system of hydroponics, this leaching is not possible. Water is recirculated through the system and fertilizer is added based on plant needs and requirements. In this way, less fertilizer is required to assure optimal plant growth and yields. The eutrophication impact of conventional farming is estimated to be around 2.7 times that of hydroponic production. Energy usage is a major factor in the assessment of sustainability of a hydroponic system. As stated before, hydroponic production yields could easily be over 10 times those of conventional production. On the other hand, this tremendous increase in production has to be fueled. This results in higher energy usage than in conventional farming. Within conventional farming, energy is generally consumed mainly by the groundwater pumping and irrigation, and secondly in fuel usage by tractors and harvesting machines, etc. Within hydroponic production, energy is mainly consumed for the pumps responsible for constant circulation of the water, supplemental lighting in case of greenhouse hydroponics, and full radiation lighting in case of indoor hydroponics like vertical farming, and heating and cooling systems. Hydroponic energy consumption is considered to be 60 to 80 times that of conventional farming. What this clearly shows is that the source of the energy is crucial in the sustainability score of a hydroponic system. Clean and local energy sources like solar, wind or hydro energy are essential in sustainable hydroponics production. Waste streams have a high share in the LCA scores of hydroponic systems. The landfill and incineration of biomass also have a substantial share in the footprint of hydroponic systems. Another large waste stream of hydroponics is found in the usage of plastic pots for plant growing. Much of the biomass and plastic waste turn up at the same pile in the end, meaning there is still a lot of terrain to win in terms of waste handling for hydroponic systems. The separation of biomass waste streams from plastic waste streams instead of landfill or incineration could reduce the climate change impact by 40 to 70% if the biomass is composted and reused. In terms of plastic waste of hydroponic systems, the climate change impact could be reduced by finding alternatives to non-renewable plastics currently used for plant pots. Examples of alternatives are the wider application of biodegradable and smart plastics, or paper pots for the plants. So, how much could hydroponics contribute in the transition towards a sustainable food production in a circular economy? Let's make up the balance. Remember, hydroponics did score worse on pre-production and post-production stages of its life cycle than conventional farming. However, when comparing hydroponics to conventional farming on the entire life cycle, hydroponics results in significantly lower impact scores in total climate change. This is due to the high efficiencies in input usage. The hydroponics uses way less water, land and fertilizer to gain the same amount of yield as conventional farming. Hydroponics does have a higher impact in terms of energy usage, making the grower's choice of energy source crucial in the footprint score. Furthermore, hydroponic systems do create waste streams in plastics and biomass. However, the biomass waste streams show many different potential value-added cascading opportunities, which all deserve better attention. Material waste stream impact could either be reduced by the use of alternatives like pots made out of paper or biodegradable plastic. Overall, the footprint of a closed hydroponic system in terms of greenhouse gas emissions is somewhere around 1.5 and 2 times lower compared to the footprint of conventional farming. The challenge for now is to make this form of food production even more sustainable by applying circular practices. We should be conscious of system design, using recyclable and durable material. We should look into how we could use wastewater as an input for hydroponics. We should focus on energy efficiency by improving our technology. And last but not least, we should be smart in the way we handle our waste. If we do all of this, hydroponics could be part of the solution and have circular food production in the future.